Alrighty, here we are on page 9 of lesson 6.07, and the topic is, here's another example of predicting products when given the reactants. The Russian Mir space station uses a chemical oxygen generator system to make oxygen for the crew. It ignites a tube of solid lithium perchlorate, LiClO4, to make oxygen and lithium chloride. Here is the chemical reaction. 1 mole of solid lithium perchlorate reacts or decomposes actually to produce 2 moles of oxygen gas and a mole of solid lithium chloride, which is just a salt. If you have 500 grams of lithium perchlorate, then how many liters of oxygen will it make, assuming standard temperature and pressure? Notice it says how many liters of oxygen. So this is not a problem where you are given mass in grams and you have to convert to mass. You're actually given mass and you have to convert to volume or liters. So whenever you hear liters, you should think 1 mole of any gas occupies 22.4 liters of space. So let me grab a snippet of this question. Bloop. And we will put it here and get to it. Here is another example for predicting products when given the reactant. So let me get to my pen, and I believe we are ready. So if I write down my given, I have been given 500 grams of lithium perchlorate, and I am trying to get to liters of oxygen gas. Okay, I can't go directly from grams of one substance, lithium perchlorate, to liters of another, oxygen, so I have to go to moles first. Moles of lithium perchlorate. From there, I can get to moles of oxygen, right, using my molar ratio, and then from that, I can convert to liters of O2. Same steps as always. X equals given over 1. Don't forget to include the substance, times sign and a line, and I just follow my arrows. From grams of lithium perchlorate, I go to moles of lithium perchlorate, times sign and a line. From there, I go to moles of O2, and from there, I can convert to liters of O2. I need my units to cancel, so grams of lithium perchlorate down and to the right, O4, moles of lithium perchlorate down and to the right, lithium perchlorate, and then moles of O2 down and to the right. I have to fill in some numbers. I know this is my easy one, right? Moles over moles tells me it's the molar ratio, and I just use the coefficients from the balanced chemical equation. So right here I have O2, so I go find O2 in the balanced chemical equation, and it has a big 2 in front of it. So a big 2 goes there. And then here I have lithium perchlorate. So I find lithium perchlorate in the balanced chemical equation, and there's nothing written, so it's a 1. So I put a big number 1 there. I know this is always a 1, and this is always a 1 because they're conversion factors. And so the next thing I have to do is figure out how much lithium perchlorate weighs. So I'm going to look at my periodic table, and I'm going to add up the weight of 1 lithium, 1 chlorine, and 4 oxygens. So 1 lithium is 6.94 plus a chlorine, which is 35.45, plus 4 oxygens. So 15.999 times 4, put that in parentheses, and I get 106.386 grams. So 1 mole of lithium perchlorate weighs 106.386 grams. And I know over here that 1 mole of any gas occupies 22.4 liters of space. Let's make sure my units cancel. Grams of lithium perchlorate are gone. Moles of lithium perchlorate are gone, and moles of O2 are gone. The only unit I'm left with is liters of O2, which is good because that's what I'm looking for. And now I'm going to do the math. So on a calculator, I'm going to open my parentheses. I'm going to do 500, and I'm going across the top, times 1, times 2, times 22.4, close my parentheses, divided by, open my parentheses, 1 times 106.386, times 1 times 1, close my parentheses, hit equals, and I get, if I could move this here, I end up with 210.5540203 liters of diatomic oxygen. My original number, the 500, only has one significant digit in it. So my answer can only have one significant digit. So I have to round that to 200 liters of diatomic oxygen. Hopefully I got it right. Let's check. I did. I got it right. The yield or result, you can see right in the middle of the screen, is 210 liters of O2. They didn't round correctly according to Stig Figs, but that happens sometimes.